Very good morning, children. Welcome to 8th Standard Science. Today, we are going to study chapter number 14 in science, that is measurement and effects of heat. And in this chapter, we are going to study sources of heat, heat transformation, types of thermometer, information about calorimeter, and expansion of heat on solid, liquid and gaseous substances.
Listen carefully to the sound of train passing over this track. What can you say about the track on which the train is going? It is not continuous. There is a gap between rails. Can you guess why? We discussed about the thermal expansion of solids, liquids and gases. Alcohol expands in thermometer and rises up. Hot air volume increases when heated. This causes its density to be smaller than the surrounding air. This results in hot air rising upward. Solids also undergo thermal expansion. Railway tracks and bridges have expansion joints to allow them to freely expand and contract with temperature changes. Different substances expand at a different rate. This is the aluminium foil pasted to the paper. If I heat this strip, it will bend in one direction. Amount of expansion for aluminium is different than that of paper. What could be the cause of this expansion? In a solid, the atoms or molecules are closely packed together. When heated, their kinetic energy pushes neighboring atoms or molecules apart from each other. This neighbor-to-neighbor pushing results in a slightly greater distance. This adds up to a larger size for the whole body. There is no preferred direction for expansion. It happens in all directions. Let me take this aluminium rod and attach it to the wooden stand. One end of the rod is fixed and it cannot move. Aluminium rod can expand only in one direction. I'll attach this mechanism to the other end. This mechanism allows us to see the small expansion of aluminium rod on the ruler. If I push here like this, pointer goes up. Let me heat the rod for 5 minutes. As it is heated, it expands. This is linear expansion of aluminium rod. Aluminium rod on expansion pushes the lever. This in turn moves the pointer on the scale upwards. Rod contracts on cooling and pointer moves down again. We know that objects expand in all directions. Will this small steel ball pass through the hole when aluminium sheet is heated? Yes. It will expand in all directions. As I heat it, aluminium expands. The hole becomes large enough for ball to pass through. We saw how rod and plate expand in 1 and 2 dimensions. If I take a cube of aluminium, how will you test if it got expanded in all directions upon heating? Solids expand in proportion to the change in temperature. Coefficient of linear thermal expansion is property of the material. It indicates the extent to which a material expands on heating. Delta L is equal to L multiplied by delta T multiplied by alpha. Change in length is delta L. Length is L. Change in temperature is delta T. Coefficient of linear expansion is alpha. Area will expand twice as much as length and volume will expand thrice as much as length. Similar to solids, liquids also expand. If I heat this container which contains alcohol, its level goes up. Just like solids, liquids have coefficient of volume thermal expansion. Let me keep a balloon on the mouth of this glass bottle. If I put this bottle in the hot water, what will happen? temperature of the glass and hence that of air inside will rise. This will result in expansion of air. As there is no way glass bottle can expand, the air moves out in the balloon and balloon expands. I'll make cork for the glass bottle from the eraser. PVC pipe is used to cut it into round shape. Let me remove balloon and place this cork instead. What will happen if I place this bottle in large container and add hot water? Air inside glass bottle expands. As cork is not allowing it to move out, pressure inside the bottle goes up and after some time cork pops up. This indicates that pressure was built up inside due to heating of the gas. We can use FET simulation to learn how pressure builds up when gas is heated. Let me put some gas in the container. Container is closed with the lid. Pressure gauge indicates the pressure inside the container. Temperature inside the container can be seen here. Right now, volume is kept constant. If I heat the container, what will happen? Pressure will increase and eventually lid will be blown away. Expansion of gas can be measured by keeping its pressure constant. This volumetric expansion coefficient is called as constant pressure expansion coefficient. Summary. We discussed about the effect of heat on expansion of solids, liquids and gases. Coefficient of linear thermal expansion is property of the material. It indicates the extent to which a material expands on heating. Change in length delta L can be calculated by multiplying the length. Change in temperature and coefficient of linear expansion alpha. Area will expand twice as much as length and volume will expand thrice as much as length. Challenge. Find out how this effect of heat plays a role in things around you. Your mother has a glass container with metal lid on it. It is very tight. She cannot open it. You also tried your best to open it, but you also failed. What will you do to open it easily? Let us take this balloon and attach it to the aluminum can. What will happen if I put this inside boiling water? Do it yourself and discuss your findings with your friends. If you happen to visit beach in summertime, you must have noticed that water is cooler than the sand which is next to it. Tar road next to the sand is much hotter than the sand. All are equally heated by the sun rays. What could be the reason for this weird behavior? You don't have to visit the beach to try this out yourself. Let us take these two containers which weigh the same. One has sand while other has water in it. They are at the same temperature. Now let us take this out in the open and keep it in the sunlight for 1 hour. If I measure the temperature of the sand and water after 1 hour, will it be the same? It is not. Temperature of sand is more than that of water. We provided the same sunlight to both the containers. What could be the reason for this? We are talking about a new term, specific heat. Specific heat is the amount of heat energy needed to raise the temperature of the substance of certain amount. Normally, it is the unit mass of substance. Rise in temperature is 1 degree. Specific heat of water is very high. That means it takes lots of heat energy to raise the temperature by 1 degree. Sand and tar has a lower specific heat. That means less heat energy is required to raise the temperature of 1 degree for sand and tar. That is the reason sand is hotter than water and tar is hotter than sand. SI unit of specific heat is joule per kilogram degree Celsius. and CGS unit of specific heat is calorie per gram degree Celsius. Scientists have already measured specific heat for various substances for us. For water, it is 1 calorie per gram degree Celsius. It means you will need to provide 1 calorie of heat to raise the temperature of 1 gram of water by 1 degree Celsius. How much is 1 calorie? We can generalize the amount of heat required. If m is the mass of the substance and we have to raise its temperature from T0 degree to T1 degree Celsius, then the amount of heat required to achieve this will be mass m multiplied by specific heat C multiplied by the temperature difference T1 minus T0. Q is the amount of heat required. Have you ever wondered why oil heats up very fast in a frying pan, but water takes so long to boil? Let me do another activity to understand specific heat better. Let me take 2 containers and fill these with water and oil. Both have the same mass, 100 gram. Both liquids are at the same temperature. We will place thermometer to observe the change in temperature as we heat the container. Time taken to raise the temperature of 100 gram of water from 70 degrees Celsius to 80 degrees Celsius is 2 minutes and 15 seconds, while time required to raise the temperature of 100 grams of oil from 70 degrees Celsius to 80 degrees Celsius is 1 minute and 5 seconds. What does this indicate? Specific heat of oil is less than that of water. It takes less amount of heat energy to raise the temperature of oil by 1 degree than that of water. Summary. We discussed an important concept called as specific heat. Amount of energy needed to raise the temperature of the substance of certain amount. We performed activity to find out why sand is hotter than water in the same environment. Tea is hot. Ice cream is cold. Which property of the object we are talking about? Yes, its temperature. We often relate the concept of temperature with hotness or coldness of the object when we feel it. We either touch it or when we feel it from a distance. Tea is very hot. It's too cold out there. Is freezing cold are the quantitative indications of the object's state. Our senses often mislead us. Take these 2 cups. One is made up of steel while the other one is made up of plastic. Let me keep these in the refrigerator. After 2 hours, I'll take these cups out. If I touch these cups, which one will be cooler? Yes, the steel one. Actually, they are at the same temperature. Why do we feel steel cup is colder than the plastic one? We feel these objects differently because metal transfers heat at a higher rate than the plastic. We need some way to measure relative hotness or coldness of the object. We are not really interested in finding out their energy transfer rate. Let me take these 2 glass containers. I'll add hot water in this container and cold water in this container. What will happen if I add a drop of ink in each one? Will it spread evenly in both the containers? It looks like ink spreads more rapidly in the container with hot water. As we know, all matters are made up of particles, atoms or molecules. These are all moving inside the matter in random motion. More movement means more energy these particles possess, and more energy means more temperature. Let's use this PhET simulation to explore movement of water molecules in different states. This is how molecules move around in ice, water and in vapor. As we heat the container, movement of molecules become more random and rigorous. Here is how neon atoms react when heated to higher temperatures. As atoms are moving all the time, they have kinetic energy. The total kinetic energy of the atoms in substance is the measure of heat contained in that substance. Temperature of the substance is related to the average kinetic energy of atoms. If two different substances have the same average kinetic energy, their temperatures are also equal. As you know, when a substance is heated, there is some change in its physical properties, like its volume. Quantitatively, how hot or cold a substance is. This enables us to compare two objects using numbers and not adjectives like hot or cold. Let me take this screw and dip it in very cold solution. If I take it out and I place it on the top of this metal block, what will happen? After some time, two objects will be at same temperature. Heat is getting transferred by means of conduction. This is the same mechanism used in devices to measure hotness or coldness of an object. Temperature is the physical quantity which expresses hotness or coldness. It is measured with a thermometer. Temperature does not measure the total amount of heat in a substance. It is the indicator of hotness or coldness. Summary. Temperature is the physical quantity which expresses hotness or coldness. It is measured with a thermometer. The total kinetic energy of the atoms in substance is the measure of heat contained in that substance. Temperature of the substance is related to the average kinetic energy of atoms. We know that any physical or chemical process is associated with heat transfer. Heat energy itself cannot be measured easily, but the temperature change caused by the flow of heat energy between objects or substances can be measured. We use a thermometer to measure temperature. Calorimeter is used to measure the amount of heat produced or absorbed in a chemical reaction. It essentially measures the temperature difference before or after the reaction. The amount of heat transferred can be calculated using the known formula. Apart from temperature, we need specific heat of substances involved and their masses. Let me heat this aluminum rod. I'll dip this in water. Water is at room temperature of 26.8 degrees Celsius. After some time, water and metal bar will be at the same temperature. How can we measure the initial temperature of metal bar using calorimeter? Calorimeter used in laboratory is very accurate. It is used to measure heat transfer during a chemical as well as a physical process. Copper vessel with stirrer is properly insulated with woolen material. This assembly is enclosed in a wooden casing. Holder is provided for thermometer. Thermometer measures the temperature before and after the reaction. Instead of standard calorimeter, we will build a simple calorimeter using just the thermocol cups. This will not be very accurate but will help us to understand how a real calorimeter works. We will use two thermocol cups. Thermocol acts as a good insulator of heat. One cup is made smaller by cutting its top part. It has a small hole. We can use this opening to insert the thermometer. Mass of water in the thermocol cup is 100 grams. Temperature of water is 26.8 degrees Celsius. This aluminum rod has a mass of 8 grams. Let us heat it for some time. We will place heated metal rod in water and cover it with the thermocol cup. This will prevent any heat loss from top. Will the temperature of water and aluminum rod be the same after some time? Yes. Temperature of metal bar will decrease and temperature of water will increase. These two will be at the same temperature after some time. It is 28.1 degrees Celsius. If we assume that there is no heat loss to the surroundings, net heat change is 0. That means total heat energy of water and metal in the container is the same. We can use this information to find out initial temperature of aluminum rod. Energy lost by metal is equal to energy gained by water. As metal loses energy to water, we will add a negative sign. Minus Qm is equal to Qw. Minus of m into Cm into delta Tm is equal to m into Cw into delta Tw. We will solve this equation to find out initial temperature of aluminum. The specific heat of water is 4.179 joules per gram degree Celsius. The specific heat of aluminum is 0.902 joules per gram degree Celsius. Temperature difference for water is equal to 28.1 degrees Celsius minus 26.8 degrees Celsius, which is 1.3 degrees Celsius. Mass of water is 100 grams. Heat energy gained by water is 100 grams multiplied by 4.179 joules per gram degree Celsius multiplied by 1.3 degrees Celsius. It is equal to 543 joules. Water received this energy from aluminum. Mass of aluminum is 8 grams. Its specific heat is 0.902 joules per gram degree Celsius. Final temperature of aluminum rod is 28.1 degrees Celsius. From the equation, we can calculate its initial temperature. So, minus of 8 gram into 0.902 joules per gram degrees Celsius into T final minus T initial degrees Celsius equal to 543 joules. So, T initial is equal to 75.31 plus 28.1. T initial is equal to 103 degrees Celsius. Summary. We discussed the need for calorimeter and built a simple version of it. Calorimeter is used to measure the amount of heat produced or absorbed in a chemical reaction. It essentially measures the temperature difference before or after the reaction. We can calculate the heat generated or absorbed or initial temperature or final temperature of the material using the known formula. Minus Qm is equal to Qw. Minus of m into Cm into delta Tm is equal to m into Cw into delta Tw. Challenge. Can you build this and measure the amount of heat generated when quicklime, that is calcium oxide, is mixed with water? You can also try other combinations like steel wool and vinegar or everyday laundry detergent with water. In previous standard, we learned about the sources of heat, how heat is transferred and effects of heat. Sun is key to our existence and is a natural source of heat energy. Earth also has heat energy known as geothermal energy. This is found in hot water and rocks in shallow regions of Earth. Wood, kerosene, coal and oil are fuels which are burned to produce heat energy. There is a chemical reaction between fuel and oxygen in the air. Heat is generated as a result of this reaction. A large amount of heat is produced in a very short time when nuclei of some elements like uranium break and undergo fission. This is nuclear energy or atomic energy. There are three ways in which heat is transferred. First one is conduction. Heat is transferred in solids by conduction. Second is convection. Convection takes place in all fluids, liquids and gases. Third one is radiation, which does not need a medium for heat transfer. We also looked at changes in the properties of substances when heat transfer occurs. Substances respond by change in length, volume when heated or cooled. State change also occurs as a result of heat transfer, like water turning into ice and water turning into water vapor. Let us explore more about heat. We will see how it is measured and its effect on properties of substances. Thermometers measure temperature due to thermal expansion of liquid inside. It can be either mercury or alcohol. Mercury, though a metal, is liquid at room temperature. Thermal expansion means increase in a volume of a substance due to increase in its temperature. As the object gets hotter, its particles move faster. The particles themselves do not expand. They just spread out so that the entire substance expands. Different substances expand by different amounts for a given temperature change. When you bring thermometer in contact with hot substance, the liquid inside the thermometer expands. Only way it can accommodate in the tube is to rise up. You measure the temperature of a substance by measuring the expansion of the liquid in the thermometer. Mercury is commonly used in thermometers. It remains liquid over large temperature ranges and expands and contracts consistently as it gets heated or cooled. Here is the regular thermometer, which can measure temperatures up to 100 degrees Celsius. Watch the level of mercury inside as I heat the water. In general, thermometers are devices that measure temperatures of the system. These devices are based on the change in the physical property of the substance when its temperature changes. It can be change in volume, dimension of the solid, pressure of gas, or color. Temperature is measured in different systems. Celsius and Kelvin are two scales which are commonly in use. You might ask how scientists decide which state of particles should be called as 0 degrees Celsius and which is 100 degrees Celsius. Celsius and centigrade are used interchangeably. Scientists decided to use water as a reference for calibration. When pure water and ice coexist at atmospheric pressure at sea level, it is defined to have temperature as 0 degrees. This is written as 0 degrees Celsius. This temperature is called as ice point of water. Mixture of steam and water at atmospheric pressure is defined to have a temperature of 100 degrees Celsius. This is called as steam point of water. We will construct a thermometer which can measure temperature in some predefined range. Our lower range will be the room temperature, that is 30 degrees Celsius, and higher range will be that of the hot water, that is 70 degrees Celsius. As mercury is hazardous and difficult to handle as well, we will use methanol. This is used in heating lamps in the laboratory. We will add some ink to make it visible. Let us use this small glass bottle and fix a thin glass tube to the lid. We will ensure that it is leak proof. Let me place this in hot water. Its temperature is 70 degrees Celsius. When heated, methanol expands. It rises up in the tube as a result of expansion. You can see the level rising. After some time, we will mark it. This is our higher range. After some time, level in the glass tube comes down. This is our lower range at room temperature. We can divide this length into 40 equal parts. This is our version of regular thermometer. It can measure temperature from 30 degrees Celsius to 70 degrees Celsius. Each division represents a change in temperature of 1 Celsius degree. Methanol contracts on cooling. We can place it in cold water. Its level in the glass tube goes down. Try to build similar thermometer for lower ranges. There are other scales like Kelvin, Fahrenheit, which are also used in the industry. Fahrenheit temperature scale is a scale based on 32 for the freezing point of water and 212 for the boiling point of water. The interval between the two being divided into 180 parts. Until the 1970s, the Fahrenheit temperature scale was in general common use in English-speaking countries. Celsius or centigrade was employed in most other countries and for scientific purposes worldwide. Since that time, however, most English-speaking countries have officially adopted the Celsius scale. The conversion formula for a temperature that is expressed in Celsius to Fahrenheit is F equal to 9 multiplied by C divided by 5 plus 32. Celsius temperature scale, also called as centigrade temperature scale, is the scale based on 0, that is for the freezing point of water, and 100 for the boiling point of water. Invented in 1742 by the Swedish astronomer Anders Celsius, it is sometimes called as centigrade scale because of the 100-degree interval between the defined points. We can use this formula to convert a temperature from its representation on the Fahrenheit scale to the Celsius scale. C equal to 5 divided by 9 multiplied by F minus 32. The Celsius scale is in general use wherever the metric units have been accepted, and it is used in scientific work everywhere. Challenge: can you find out the temperature of the brine solution in degrees Celsius? Its temperature is 7.9 degree Fahrenheit. Kelvin temperature scale is the base unit of thermodynamic temperature measurement in the international system. Many physical laws and formulae can be expressed more simply when an absolute temperature scale is used. Accordingly, the Kelvin scale has been adopted as the international standard for scientific temperature measurement. The Kelvin scale is related to Celsius scale. The difference between the freezing and boiling point of water is 100 degrees in each, so that the Kelvin has the same magnitude as the degree Celsius. Can you build your own thermometer scale by using metals like aluminum or copper? If I use alcohol instead of mercury in the thermometer, will the distance between 0 degrees Celsius and 100 degrees Celsius mark be the same? Can we use mercury thermometer to measure temperatures below minus 40 degrees Celsius? Discuss with your friends and find out. Not all thermometers use liquid for measuring temperature. You might have seen different types of thermometers in the market. This probe thermometer is used in catering for measuring temperatures of food, liquids and semi-solids. The digital display is easy to read. This thermometer is based on internal sensor. This is an infrared thermometer. We can measure temperature of an object without touching it. It has a sensor in the front which records the temperature of an object. Container to your right has water at room temperature, while the one on your left has hot water. If we aim this infrared thermometer at left container, it reads temperature of hot water, that is 66.7 degrees Celsius. Point it at the water in container, it reads 24.7 degrees Celsius. Infrared thermometers are used for measuring extremely high or low surface temperatures. In these cases, it is difficult to go near the object. Analog thermometers are common in use at home. These thermometers are either liquid or bimetallic strips to measure the temperature. Clinical thermometer is used to measure human body temperature. They are very accurate and sensitive. Most show both Fahrenheit as well as Celsius temperature scales. The scale runs from 35 degrees Celsius to 42 degrees Celsius. Lab thermometers are used in laboratories for high accuracy with temperature ranges from -10 degrees Celsius to even 110 degrees Celsius. Though usage of mercury is common, newer thermometers use alternative to mercury like sensors or alcohol. Summary: we discussed how temperature is measured and working of thermometer. Scale of temperature is a way to measure temperature quantitatively. Empirical scales measure the quantity of heat in a system in relation to a fixed parameter, a thermometer. They are not absolute measures. That is why scales vary. We discussed about 3 scales: Celsius, Fahrenheit and Kelvin. Challenge: its temperature is also higher than the aluminum block. When I place these two in contact, which way heat energy will flow? Hammer to aluminum or aluminum to hammer? When water is heated, its temperature rises by 10 degrees Celsius. How much it must have been increased in degrees Kelvin?
So student, in this video we shall learn about effects of heat. So let's see one by one. So first, effects of heat. So student, there are 2 effects of heat on matter. First is expansion and contraction, and second effect of heat is change of state. So student, change of state. So if we take an example of ice, which is there in solid state. So when on heating ice, its state will be changed. That means solid to it will convert into liquid, and if we heat liquid, then it will convert into the gas or vapor. So this is how the change of state takes place of matter on heating. So first we are going to learn about expansion. So let's see what it is. When heat is given to any substance, its temperature increases and it expands, and its expansion depends on the increase in its temperature. So student, you can see in the picture that while on heating the liquid or any substance, liquid, what happens, its temperature will increases and its level or its volume also increases. That means it is expansion. So this is the expansion of liquid. And solids, liquids and gases all expand on receiving heat. That means when we heat any substance, it will expand or its volume will increases. So first we shall learn about the expansion of solid. So in expansion of solid, we are going to learn the 3 types, that is linear expansion in rod, aerial expansion in thin sheet, and volumetric expansion, that is in solid cube. So let's have a look on them. So expansion of solid. So in expansion of solid, first is linear expansion. So the linear expansion of a solid is the increase in length of a wire or a rod of a solid due to increase in its temperature. That means when we heat the rod of a solid material, so what happened on heating, its length will increases, and this is linear expansion of solid. So when we increase the temperature of a rod of length L1,
and L1. So what happened? You can see in the picture, when we increase the temperature of a rod of length L1 from T1, temperature T1 to T2. That means when temperature increases, what happens? Its length becomes L2. Okay, L1 to L2 on heating. So the change in length is proportional to the original length and the increase in temperature, that is delta T. And delta T is nothing but T2 minus T1. This is temperature difference. And the change in length is proportional to the original length and the increase in temperature. So we can write the change in length as follows. So change in length is directly proportional to its original length multiplied by change in temperature. So in numerical mathematical form, we can write it as L2 minus L1, that is change in length, and which is directly proportional to original length. And what is our original length? It is L1, and multiplied by change in temperature, that is delta T. So L2 minus L1 is equals to lambda multiplied by L1 multiplied by delta T, and L2 is nothing but equal to L1. So if we take L1 as a common, we can get in bracket 1 plus lambda delta T. So this is our final equation, and here lambda is the constant of proportionality and it is called the coefficient of linear expansion of solid substance. So this is the linear expansion of solid substance, and this is the equation of this. Now next is, if we take two rods of different substance, both having the same length, and increase the temperature by the same amount, the rod of the substance having higher expansion coefficient will expand more, and thus the increase in its length will be larger. An equation can be written like this, that is lambda. And what is lambda? This is a coefficient of linear expansion. So lambda will be equal to L2 minus L1 divided by L1 multiplied by delta T. And thus the expansion coefficient, that is lambda, is the change in length of a rod of unit length when its temperature is increased by 1 degree. And the unit of expansion coefficient is the inverse of the unit of temperature, that is 1 divided by 1 per degree Celsius. So now we are going to learn the areal expansion of solid in a thin sheet. So similar to a linear expansion, the area of a sheet, that is thin sheet of a solid material, also increases on heating. This is called the areal expansion of solid. That means when we heat the solid material, solid sheet, what happens? Its area will increase. So this is the areal expansion of solid, and this is given by the following formula. So it is areal expansion, so that's why it is formula can be written as A2 is equals to A1 multiplied into bracket 1 plus sigma delta T. So this is the formula of areal expansion of solid, and here delta T is the change in temperature, and A1 and A2 are the initial and final areas of a sheet. So A1 is the initial area of a sheet and A2 is the final area of a sheet, and sigma is the coefficient of areal expansion of the solid. So in case of a linear expansion, we have lambda. So this was that was the coefficient of linear expansion, and sigma is the coefficient of areal expansion. Next is a volumetric expansion of solid. So this is the third type of expansion of solid in a solid cube. So similar to a sheet, a three-dimensional piece of a solid expands on all sides when heated, and its volume will increases. So volumetric means its volume will be increases on heating, and this is called the volumetric expansion of a solid, and this is given by the following formula, that is V2. It is volumetric, so V2 will be equal to V1 into bracket 1 plus beta delta T. Here delta T is the change in temperature, and V1 and V2 are the initial and final volumes of the solid. and beta is the volumetric expansion coefficient of the solid. So these three coefficient you have to remember, that is lambda for the linear coefficient of linear expansion, and sigma means coefficient of areal expansion, and beta is the coefficient of volumetric expansion. Do you know, students, here have you seen rails? They are not continuous. A small gap is kept between them at regular intervals, and this is shown in the diagram. You can see in the diagram, and this is kept to accommodate the change in length of the rails with change in temperature. And if this gap is not kept, then if this gap is not kept, what happened? Then the rail will get distorted due to expansion in summer, which may lead to accident. So in summer temperature is more, so that's why to reduce the expansion or to stop the expansion, the gap is kept between the railway tracks. And similar to rails, the length of bridges can also increases due to expansion in summer. And the length of the 18 km long Great Belt Bridge in Denmark increases by 4.7 meter in summer, and therefore provision is made in the construction of the bridges to accommodate. So next is the expansion in liquids. Let's see. So expansion of liquid. A liquid does not have a definite shape, but it has a definite volume. So we can define a volumetric expansion coefficient for a liquid as by this formula. So the formula is V2 is equals to V1 into 1 plus beta delta T, and here delta T is the change in temperature, and V1 is the initial volume and V2 is the final volume of the liquid, and beta is the volumetric expansion coefficient of the liquid. Now anomalous expansion of water. So water does not expand continuously with temperature rise, and from 0 degrees Celsius to 4 degrees Celsius, what happened? Water tends to contract, or rather the volume decreases. That means instead of expanding, it will contracting between 0 to 4 degrees Celsius, and its volume will be decreases, and until it reaches 4 degrees Celsius. So from 4 degrees Celsius to 100 degrees Celsius, it expands normally as most liquids. So the behavior of water from 0 degrees Celsius to 4 degrees Celsius, it is what it is called as an anomalous or abnormal behavior of water, and it is different from other liquid. It's only there for water. Next we have is expansion of gases. So student, a gas does not even have a fixed volume, and gas expands on heating, but if the gas is kept in a closed box, you can see in the picture that if the gas is closed, if the gas is kept in a closed container, its volume cannot increases, but its pressure increases. Okay, and this you can see the picture also. And the expansion of a gas is measured by keeping its pressure constant, and this volumetric expansion coefficient is called the constant pressure expansion coefficient, and it is given by this formula, and the formula is V2 is equals to V1 into 1 plus beta delta T. So this is the equation for the expansion of gases, and here the delta T is the change in temperature, and V1 and V2 are the initial and final volume of the gases, of the gas at constant pressure. So the pressure is constant, and beta is the constant pressure expansion coefficient of the gas. So student, this was all about this chapter, and I hope you all have understood about this expansion concept.
So children, I hope you all have understood the chapter well. Okay, solve the exercise by given PDF in your CW. Okay children, thank you.